Hello, welcome to this video about the summary of the semi-discrete form. So the semi-discrete form we obtained is more or less listed here with the boundary conditions. So we have the mass matrix times the unknown, the second derivative of the pressure, plus the stiffness matrix times the acoustic pressure is equal to a forcing. We have two initial conditions. First one is acting on the pressure, acoustic pressure itself, that we have an initial state of the acoustic pressure, and the second one is that the time derivative of the acoustic pressure is also certain in the domain. And now we have this semi-discrete form, which is a number of ordinary differential equations which we would like to solve, but typically we need an algebraic system that is solvable with an algebraic solver in order to obtain the acoustic pressure itself, and therefore we need some time discretization to obtain the full discrete algebraic system, and the time could be discretized in the following ways. First of all, we could use time stepping scheme. We can use some sort of eigenvalue analysis of the system of equations. There we get some insight. We can use the Fourier transform to get the ODEs into an algebraic system of equation. We can use the Laplace transform, or we can even do the space-time finite element formulation, which is more or less advanced, and is treating the time coordinates similar to spatial coordinates. Thank you for watching this summary video. In the next video I would like to tell you more insights on how to do time discretization and then come to the algebraic system. Thank you.